Okay, so the first problem on my correction list is going to be problem number 3. And that's going to be a car is traveling at 75 feet per second, so the initial velocity is equal to 75 feet per second. When the brakes are fully applied, producing a constant deceleration of 15 feet per second squared, so we know that acceleration A is negative 15 feet per second squared. What is the distance traveled when the car comes to a stop? So the final velocity, the car will stop, and the final velocity is going to be 0 feet per second. And it's asking us to find delta y, or the change in the distance. Find delta, or not delta y, I'm sorry, delta x. Find delta x. So we know that the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the change in the distance. So we can rearrange that to be the change in the distance is equal to the final velocity squared minus the initial velocity squared all over 2 times the acceleration. So then we can plug in our values. We know that delta x is going to be equal to the final velocity being 0 meters per second squared minus the initial velocity of 75. I mean, not meters, feet. Let's just do 75 squared times 2 times negative 15. And we end up with delta x being equal to 75 squared. So this is going to be negative 5625 over negative 30. The negatives are going to cancel each other out, and we're going to be left with delta x is equal to, divided by 30, 187.5 meters, or feet, not meters. That's the final answer for number 3. The next question is number 7 from exam 1. And that's going to be find the volume of a solid that has an elliptical base with boundary 4x squared plus y squared equals 4, with the cross sections of the solid perpendicular to the x-axis being semicircled. So they give us 4x squared plus y squared is equal to 4. And they are saying that the base of the solid is going to be an ellipse, and that the cross sections are going to be perpendicular to the x-axis. So these cross sections are going to run like this, and they're going to be semicircles. So we know that the width of these cross sections are going to be dx. We're going to have dx as our width. And we know that a area of a circle is pi r squared, and a semicircle is going to be half that, so it's going to be pi r squared over 2. So our integral is going to be the integral from a to b of pi r squared over 2 in terms of dx. So a is going to be our bounds. Okay, so our bounds are going to be, first of all, before we even get to that, the radius of these circles are going to equal y. That's going to be our radius. And y is going to be equal, if we rearrange this portion, y should be equal to the square root of 4 minus 4x squared. So we have y. Now we just need our bounds of integration. If we set 4 minus 4x squared under the root equal to 0, we'll get, we'll square both sides. We're still going to have 0 here. We're going to have 4 minus 4x squared. Let's move this stuff around. Let's add 4x squared to this side. We're going to have 4x squared on this side. We're going to have 4 on this side. Divide by 4x squared is going to be equal to 1. So then finally we're going to have x is equal to plus or minus 1. So we're going to have -1, and we're going to have 1. Those are going to be our bounds of integration. So a is going to equal -1, b is going to equal 1. So now we're ready to set up the integral. The integral is going to be from -1 to 1 of pi r equaling this. R is going to be square root of 4 minus 4x squared all over 2 in terms of dx. And okay, so the first thing we can do is pull out this pi halves. So we're going to have pi over 2, the integral from -1 to 1 of 4 minus 4x squared under the square root squared dx. The square root and the raising to second power is going to cancel out. We're going to be left with pi over 2, the integral from -1 to 1 of 4 minus 4x squared dx. Now we're ready to integrate. We're going to have pi over 2. We're going to have 4 minus, oh, I'm sorry, we're going to have 4x minus, let's see, we're going to take the 3 under, so 4 over 3x to the third, and we're going to evaluate this from -1 to 1, so that we have pi halves 4 times 1 minus 4 over 3 times 1 to the third minus 4 times -1 minus 4 over 3, -1 to the third, and now it's just a matter of simplifying all of this. We have 4 minus 1 to the third is 1, so we got minus 4 over 3. Let's keep that. 4 times -1 is -4. -1 to the third is going to be -1. And then -1 times 4 over 3 is going to be -4 over 3. Negative minus negative is positive, so we're going to have positive 4 over 3. And then, so pi halves. We need to multiply this times 3, 4, 8, 12. 12 minus 4 is 8. So we're going to have 8 over 3 minus, let's see, we got -4 plus 4 over 3 is the same thing, so -12 plus 4 is -8. -8 over 3. This is end up being positive. Got pi over 2. 8 plus 8 is 16 over 3. So we have 16 pi over 6. And what does this equal? This is going to be equal to 8 pi over 3. And that's our final answer. 8 pi over 3. Okay. So the last one is going to be number 8. And this says use a method of cylindrical shells. So we need to use the shell method. Use shell. And it's find the volume generated by rotating the region bounded by the given curves about the line y equals -1. So we're going about y is equal to -1. And we're given two separate functions. We have y is equal to x squared, and we have x is equal to y squared. And if we look at this on Desmos, and we just put, I already have this actually popped up on Desmos, it looks something like this. We have -1 here, our axis of rotation. And we're going to have something like this, and on the other side we're going to have another little something like this. It asks us to use the shell method, which means that our slices need to be parallel with the axis of rotation. So our slices are going to kind of be like this, which means our width is going to be in dx. So we're not going to be able to use this x equals y squared, so we just need to convert this into x equals the square root of x. And that's going to be our upper. And y is equal to x squared is going to be our lower. And what we're looking for is 2 pi, the integral from a to b, of the radius r times the height, and this is going to be in terms of dx. So our r is actually just going to be equal to x. This is our r, and that's just going to be equal to x. And our height is going to be equal to the upper function minus the lower function, the upper function being the square root of x and the lower function being x squared. So we have h is equal to the square root of x minus x squared. So we're ready to set up this integral. Oh, the bounds are going to be from 0 to 1. Here we have 0, and from here we have 1. When x squared is equal to the square root of x, we get 1. So a is equal to 1, b is equal to, a is equal to 0, b is equal to 1. Our integral is going to be 2 pi, integral from 0 to 1. Our radius is going to be x, and our height is going to be the square root of x minus x squared in terms of dx. So let's just start changing some things around here. So this is 1. The exponent here is 1. So 1 plus 1/2 is going to be 2 over 2 plus 1 over 2, which is 3 over 2. So we're going to have x to the 3/2 minus 1 plus 2, which is x to the 3rd, and that's going to be dx. And now we're ready to integrate. We're going to have 2 pi, and 3/2 plus 1 is going to be 3 over 2 plus 2 over 2, which is 5 over 2, which is going to be 2 over 5, x 5 over 2, minus x to the 4th, 1 over 4, x to the 4th. And that's going to be evaluated from 0 to 1. So that we have 2 pi is going to be equal to 2 over 5, keep everything clean here, 1 to the 5/2 minus 1 over 4, 1 to the 4th, all minus everything to the 0. 0 to the 4, 0 to the 4, so this is just going to be 0. Okay, so we have 2 pi. 1 to the 5/2 is just going to be 1. So we're just going to have 2 over 5. 1 to the 4th is just 1, minus 1 over 4. Okay. So 5 times 4 is 20. 20 divided by 5 is 4. 4 times 2 is 8. 5 times 4 is 20. 20 divided by 4 is 5. 5 times 1 is 5, all over 20. 2 pi. So that we have 2 pi, 3 over 20. 3 over 20, which is 6 over 20. So we're going to have 6 pi over 20. And this is all going to be equal to 3 pi over 10. And that's our final answer, 3 pi over 10.